In this lesson, we're going to practice writing radical expressions as rational exponents. So they're going to start off in radical form, and we're going to manipulate them into a rational exponent, which basically just means a fractional exponent. So let's see what we got. So for the first one, we're going to have the cube root of x. So we'll rewrite that as x. The power on x is a 1, so it'll just be a 1/3 power. So the power is the numerator, and the root becomes the denominator. All right. So if we had another one, 1 over the 4th root of x squared. So first thing is, let's take it out of the radical form and let's write it as a rational exponent. So that will be your numerator, the 2, and the 4 will be your denominator. And on all of these, you're going to try and simplify them, reduce them as far as you can. So 2/4 reduces to 1/2. And then potentially you can leave your answer like this if they want you to leave everything as a positive exponent, or if they don't want any fractions at all within this, then you can pull that x up, except it's going to change your exponent into a negative. So these are equivalent, so it just depends on kind of what the directions are asking. All right, third one. So for the third one, we're taking the cube root of 8x squared. And so when you have pieces multiplied together inside of a root, you can always individually look at them. So you can break it up into the cube root of 8 times the cube root of x squared, and then we can do it individually. So the cube root of 8 is 2, and we can't cube root the x squared, so we'll just basically do the exact same thing we did with the others. So this will become x to the 2/3 power. All right. So what if you have the 5th root of x to the 10th, y to the 20th? So let me show you a little bit of a different approach that also would have worked just as easily on any of these. So you could also take this, and right from the very beginning, just take this 5th root and write it as a 1/5 power. They're equivalent to each other. So now we're going to use some of our properties of exponents, where we have powers raised to powers, so that 1/5 is going to be applied to everything on the inside. So you're going to have x to the 10/5 when you multiply 1/5 times 10, and y to the 20th, 20/5. When you multiply those powers together, because powers to powers are going to multiply, and then we can simplify our fractions. So 10/5 becomes x squared and y to the 4th. So you have different ways of doing different problems, and it just kind of get used to trying different methods and see what works. You could have done that to the very beginning on this too, but sometimes it's a little easier with numbers to kind of leave them as radicals, and then you can manipulate them a little bit easier. So what if you take the exact same problem, but it's going to be the 4th root? Same thing. So start off with x to the 10th, y to the 20th, 1/4 power. So powers to powers, same thing. We're going to apply that 1/4 power to each of them. So that's going to be x to the 10/4 and y to the 20/4. And we will just reduce our fractions. Now that 4 doesn't go into 10, but we can reduce it a little bit. So 2 goes into both of them. So we'll make that x to the 5/2 and y to the 5th if you reduce that one. All right. So number 6. So if you have, here's one that looks ugly. The square root and the cube root the square root of the cube root of 3x to the second. How do you deal with that? Well, this method is probably one of your easier ones. So you're just going to start writing things in parentheses. So we'll kind of work our way out here. First off, we have 3x squared. And then we have the cube root of that. So we're going to take and put another set of parentheses, and that's a 1/3 power. Cube root is equivalent to a 1/3 power. Then you have the square root. So you have this piece being squared, raised to the 1/3 power, raised to the 1/2 power, but all of these powers are powers raised to powers, so they all just multiply together. So we can and we can do this in any order we want. So we could take 2 times 1/3 times 1/2, or 1/2 times 2, and those two values are actually going to simplify each other because half of 2 is 1, so they'll cancel each other away, make that a 1. So really you're only left with a 1/3 power. So that becomes the 3x piece that was the base basically raised to all these powers to the 1/3 power. All right, number 7. So what if we have x to the negative 3/2 raised to the positive 2/3? Very similar to what we had going on here. Powers raised to powers, multiply them together, but they are actually reciprocals of each other, other than the negative sign. So reciprocals end up canceling each other out very nicely. The 3 cancels the 3, and the 2 cancels the 2, and you're just left with 1s on every single piece. So if you multiply that all together, that's really just going to become x to the negative 1. And again, depending upon how they want their answer written, if they don't want any fractions, then we'll leave it like this. But probably more often than not, we won't want answers written with negative exponents, so that'll just come down. And the power is still technically 1, but we don't need to write it.